What's up, math fans? Today I want to talk about the distance formula. Distance formula works in coordinate geometry. Coordinate geometry means I'm putting points on a plane and I'm finding the distance between 2 points. And distance is helpful in a lot of situations. Just think about being out in the street and you want to go from one place to another place. Hey, how far is the store from here? Hey, how do I get to the gas station? How many blocks do I need to go? So distance is from here to here. All right, so here's a real basic example. What is the distance from 60th Street to 66th Street? And I'm just gonna walk, to keep it simple, I'm gonna walk up a straight avenue. So let's say you're in Manhattan and you wanna walk up, I don't know, 7th Avenue, and I wanna go from 60th to 66th Street. How far is that? You should have an answer in your head. I'm gonna do it using a number line. Number line is kind of like a map. If you're looking at a map, it's basically a number line. So if I wanna go from 60th to 66th Street, that's one number line. When we get to graphs, that's two number lines. But it's the same idea. So let's skip a bunch of numbers. I don't want to start from 0. I'll start from 59. Here's 60, 61, 62, 63, 64, 65. Here's 66. I'll even go to 67. So let's say you're standing on 60th and you want to go to 66. How do you get from here to here? Simple as counting boxes. 1, 2, 3, 4, 5, 6. Those are arrows. I don't look sloppy. Those are arrows. I walk 6 blocks to get there. All right? It's strange. I watch some people count. They're standing on 60th and they still count 60th as 1. They go 1, 2, 3, 4. No. You don't count until you get to the next block. You're already here. So then you go 1. You're already standing here. It's not 1. You go here. Now it's 1. Okay? So what was my answer? 6 blocks. You count boxes. What if it's too far away and you don't have time to graph that, or you don't have time to count boxes? When I first asked the question, I'm pretty sure you had an answer in your head. What'd you do? 66 minus 60, hopefully, and you got 6. So your answer is 6 blocks or 6 units or 6 streets, whatever. So the clue is subtract. To find distance, subtract. Keep that in mind. It's going to get more complicated. That only works if you're going straight. Here's what I mean. From 2-3 to 7-3, how far is that? How many units is that? So if you know my secret, you can already give me an answer, but I want to visualize it. So here's 1, 2, 1, 2, 3. Here's 2, 3, right? And then here's 3, 4, 5, 6, 7. Here's 7, 3. How do you get from here to here? Well, if it helps, I'll connect the dots. How long is that line? What is the length or distance of this line? So keep those words in mind too. Length and distance are very similar in mathematics. So what is the distance from here to here, or what is the length of the green line? Do the same thing. I started at 2, 3. So this is 2 on the x-axis, and I got to 7, 3. So 7 on the x-axis. So that's 1, 2, 3, 4, 5 units, 5 spaces, 5 blocks, 5 whatever. So that's 5, right? I don't have time for that. What if the numbers were bigger? Let me just subtract 7 minus 2 and I get my answer. So subtracting is the shortcut. Subtracting is going to lead me to a formula. Keep this in mind. A point is always x comma y. Here's another point. That's another x comma y. So just to differentiate, make this your first x, so x1 and y1, and then make this your second x, so call this x2, y2. Okay? So my formula is x2 minus x1. x2 minus x1. That's how I got 7 minus 2 equals 5. 7 minus 2 equals 5. That's so easy because it's straight. It's a horizontal line. Same thing would work for a vertical line. You just subtract the coordinates that change. Don't touch the other ones. But what if they both change? How would I get from 2, 3 to, let's say, 7, 15? And no, that's not the time that it is right now, although we're pretty close. 2, 3 to 7, 15. How do you get from here to here? Well, you can imagine it on the graph. Here's 2, 3. And 7, 15 is 3, 4, 5, 6, 7. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 7, 15 is right here. So I want the distance from 2, 3 to 7, 15. You can connect it and tell me the length of that green line, but you cannot count spaces on a diagonal, so it's not that easy. So this time I gotta go across and then up. I go across and then up. I created a right triangle. Guess what? The Pythagorean theorem helps you in so many different situations. It really does. So what is the length of the base? Oh, let's see, I started here at 2, and I went all the way to 7. How did I get there? 7 minus 2 is 5. Now here I am up at 3, and I want to go all the way up to 15. How do I go from 3 to 15? Well, that's 15 minus 3, which is 12. Now I'm going to do my a squared plus my b squared equals c squared. That's going to give me the direct distance, because we don't have time to go across and up. I want the direct distance, the length. So, what's that? 25 plus 144 equals c squared. 169 equals c squared. Take the square root of both sides, and c equals 13. 13. All right? And that's how you find one point to another point. You plot it, you create a right triangle, and you use your Pythagorean theorem. A squared plus b squared equals c squared. However, if the numbers are too big or too frustrating to plot, and you don't have enough space, there is a formula. So stick around for that formula. Remember how I got the base of my triangle? I did x2 minus x1. I did 7 minus 2 to get that 5. But then I had to square it because my formula said a squared. Plus. Remember how I got the b? I did 15 minus 3 to get that 12. So really that was y2 minus y1. I had to square it, and that gave me the hypotenuse. Called it c squared. You can call it length squared or distance squared. I'll use d for distance, d squared. So if I want to get d alone, watch this. Take the square root of both sides, just like we did earlier. The square root of d squared is d equals the square root of whatever that is inside. It looks crazy, but it's not. It's just x2 minus x1, y2 minus y1. This minus this plus this, this minus this squared plus this minus this squared. Looks crazy, it's not. We just did it. So here's your distance formula. x2 minus x1 squared plus y2 minus y1 squared. And then the last step at the end, you take the square root and you get your distance. Okay? That's it. That's your distance formula. And you can use it to find any 2 points. So if you looked at that word problem, they're asking for the radius. Basically, you're imagining that you're looking at a diameter, right? So a diameter of a circle has endpoints here and here, A and B. So I plotted A, I plotted B. You can connect them. You can imagine there's a circle there. And that's my diameter, all right? Not drawn to scale, looks a little lopsided. This is my diameter. I need the length of that diameter so that when I find the radius, I'm gonna divide by 2. So what's the length? I don't know, I guess it's the distance between the points. So d equals square root of, let me label my points, x1, y1, x2, y2, and let's do it. What is it? 3 minus negative 3, gotta square it, plus 13 minus 5, gotta square that. That should be inside. D equals square root of 3 minus negative 3 is really 3 plus 3, which is 6 squared, plus 13 minus 5 is 8 squared. So D equals the square root of 36 plus 64. So D equals the square root of 100, and the square root of 100 is 10. So the distance from here to here is 10. Your diameter is 10, but I asked for radius. Think ahead. R equals 10 divided by 2, also known as 5. Remember this distance formula, it comes from the Pythagorean theorem. It works to find the distance between any 2 points on a graph. Thanks for watching. See ya.